This is the last part of our unit, so we've been working on dealing with radicals, and one of the times when radicals comes up is when we are working with the quadratic formula. Does this look familiar to y'all? Seen that thing before? What happens is if we're trying to solve this thing, we can use the quadratic formula. So to give you guys an example, yesterday we set up, or the other day we set up questions like this. X squared minus 4x minus 3 is equal to 0. We could factor that. What does that factor to? Well, I'm sorry, plus 3. There we go. What does that factor to? X and x, and then what's it going to be? Yep, minus 3 and minus 1. So you have solutions of 3 and 1, right? Wouldn't it be nice if there was a formula that could just come up with 3 and 1 in case you forget how to factor? Or suppose that it didn't factor. Suppose you had x squared minus 4x minus 3, like I wrote right away. That does not factor. We don't know how that breaks down into two parts. And so therefore, in that situation, you must use the quadratic formula. In this case, you could choose to use the quadratic formula or factor. Factor or quadratic formula, either one. So quadratic formula can be very, very useful in that way. And as you take a college level math class, we expect that you're able to handle the quadratic formula pretty easily. So the quadratic formula has a couple parts to it. And the part that sits underneath the square root, we call it the discriminant. Because the square root of things, for example, like the square root of 25 is 5. The square root of 0 is 0. The square root of negative 9 is 3i. When you have square roots of negatives, you have what we call imaginary solutions. That's no bueno for us when we're using the quadratic formula. Okay? So we like to figure out what we have for the square root, or for the b squared minus 4ac. It's really important to know, do we get a positive value, do we get 0, or do we get a negative value? And so if you end up with a positive number underneath the square root sign, you have two solutions. And that means if you were to look at the graph of the parabola, it would look something like this. It would cross the x-axis in two locations. That's what that means. Suppose the value of the discriminant was 0. Then you have exactly one solution. It means that the graph would look something like this. It would come down, it would just barely touch, and it would bounce back off. So it would just touch once. Okay. And then, if you have a negative number underneath the square root sign, there are 0 real solutions. They're what we call two imaginary. But there are no real solutions. And what that means is the graph would not cross the x-axis. It would look something like that. Never crosses. So the first thing we're going to do is we're just going to find the value of the discriminant. Okay. So what that means is this. I'm going to write down negative b plus or minus the square root of b squared minus 4ac all divided by twice the a value. You don't have to memorize the quadratic formula for the test, but the quadratic formula is hopefully something that you are able to kind of memorize over time here. Okay. So when it says find the value of the discriminant is simply b squared minus 4ac. So it says find the value of the discriminant and determine the number and types of solutions that it has. So A is the number in front of x squared. What's the number in front of x squared? 1. B is the number in front of x. -6. And then C is the number that doesn't have, it's just the constant, doesn't have any variable attached to it. So we just have 9. When you square something, it always becomes positive. So B squared would be 36 minus 4 times A times C. A is 1 and C is 9. So you get 36 minus 36, which is 0. So if the value of the discriminant is 0, how many solutions are you going to have? 1 solution. Now, if you want to see how that works out, this actually does factor to x minus 3 times x minus 3. What's your solution? 3. See how it happens twice? So 3 and 3. So it's just 1 solution of 3. Okay, so you can see how it works out. Let's try this guy. Got A, B, and C. A is 2, B is -1, and C is -3. What's B squared? 1. Minus 4 times A is 2, and C is -3. Okay, here we go. How many negatives do I have? I've got this one right here, then I got a subtraction sign. So what's going to happen? It's going to turn to positive. I'll write it out. You can see it's 1 minus 4 times 2 is 8 times -3 is -25. So when you see you have 2 negatives like that, you can just turn it into addition because it's going to change to positive. Whoop, I'm sorry, I wrote 25, 24. I was thinking ahead. Sorry about that. And 1 plus 24 is 25. So the value of the discriminant is 25. That's a positive number. So how many solutions do you have? 2 solutions. Try number 3 on your own. Go. What up? So I got 2 solutions in that. I came up with a positive 9. Very good. Okay, we do the last one. A is 1, B is 4, C is 3. B squared is 16 minus 4 times A is 1 and C is 3. So that gives me 16 minus 12. I get 4 because it's positive. How many solutions do I have? I have 2 solutions. Okay. All right, flip it over. Before we actually implement the quadratic formula, I want you to know that sometimes you end up with expressions that look like this in the quadratic formula. We have to be able to simplify them. And so I want to go over kind of the simplifying process here. You see 6 plus or minus the square root of 24 over 4. That is not simplified because you could take a perfect square out of 24. What perfect square can you take out of 24? What perfect square divides evenly into 24? Is 4. 4 times 6. So remember, we simplify that because the square root of 4 is 2. So I have 6 plus or minus 2 roots of 6 over 4. And then what you can look at is these three terms. Don't worry about the radical, but these are all divisible by what? 2. So if you divide them all by 2, you get 3 plus or minus 1 root of 6 all over 2. And that's your answer. Sometimes the results that you get from the quadratic formula are kind of messy. And we'll show you what that looks like as we move forward, but that's how we reduce it. We won't do all these, we'll do a couple of these. How about number 6? What perfect square can you take out of 45? Yep, so I've got 9 and I've got 5. Square root of 9 is 3, so I got 3 plus or minus 3 roots of 5 over 9. And then I look at these three numbers. They're all divisible by 3. So I divide them all by 3 and I get 1 plus or minus the root of 5 all over 3. Let's do one more together. Let's do problem 9. What perfect square divides evenly into 200? 100. So 6 plus or minus the square root of 100 times the square root of 2 all over 10. Square root of 100 is 10. So I have 6 plus or minus 10 roots of 2 over 10. Now, sometimes people might be tempted to just cross off these 10s. You can't do that. You have to look at every piece in the numerator and then in the denominator say they are all divisible by 2. So divide them by 2 and we get 3 plus or minus 5 roots of 2 over 5. Those are kind of the basics of making use of the parts of the quadratic formula. So the last thing to do is put the entire quadratic formula to work. We would like to solve these 4 problems using the quadratic formula. Okay. And this will end our unit. I'll write down the quadratic formula so we can all see it. Negative b plus or minus the square root of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. Do you remember the song that goes with the quadratic formula? Well, I'm not really a quadratic formula song singer guy, but I do know sometimes students tell me that they remember the song for the quadratic formula. And since you asked me, I'll do my best. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Why are you laughing at me? All right, let's make good of this, okay? We want to solve this equation. Now, I would never use a quadratic formula here. I would just factor it. But some of these, I would not factor. I would definitely use the quadratic formula because you got to figure out how it works out. So in this situation right here, I have negative b. What is negative b? So the opposite of your b value. Positive 3 plus or minus the square root of. What's b squared? 9. Minus 4 times what's a? 1 times c? Negative 18. All divided by twice the a value. What's twice the a value? It's 2. Now, if you make a mistake on the inside for the discriminant, then everything falls apart. So if you can't figure it out, then just go ahead and type in 9 minus 4 times 1 times negative 18. And if you use your phones as a calculator, you're taking a risk because they don't know order of operations. I get 81. 3 plus or minus the square root of 81 over 2. Is 81 a perfect square? Yeah, so take the square root of 81. What is the square root of 81? 9. So because there was a positive value underneath the square root sign, I know there's how many solutions? There's 2. We're going to find them. One of them is 3 plus 9 divided by 2. The other one is 3 minus 9 divided by 2. Sorry. What's 3 plus 9? Divided by 2? So 6 is one of the solutions. 3 minus 9 is negative 6 divided by 2 is negative 3. My two solutions are 6 and negative 3. Not too bad? Remember the first time you saw the quadratic formula, you're like, oh my gosh, nobody can do that. It's impossible. Now it's like no big deal because you're a super smart, right? Okay, number 12. Remember, I look at my formula, I start with negative b. What's negative b? The opposite of this, which would be positive 11 plus or minus the square root of square b. What's negative 11 squared? 121 minus 4 times a is 2 times c is 5. Divided by twice the a value, 4. Okay, this part underneath the square root, again, if you can't figure that out, you go to your calculator. I happen to know that 4 times 2 is 8 times 5 is 40. And 121 minus 40 is going to be 81. If you don't believe me, you can type it in. 121 minus 4 times 2 times 5. And I get 81. So sure enough, 11 plus or minus the root of 81 over 4. I got a positive number underneath my square root sign. That means I have all my solutions. I've got 2. Okay, I got 2 solutions. Is there a perfect square of 81? Yep. So I take the square root of 81 and I get, again, 9 divided by 4. So I'm going to simplify this. I've got 11 plus 9 over 4, and I've got 11 minus 9 over 4. Those are my 2 solutions. One's the plus, one's the minus. 11 plus 9, 20 divided by 4. So 5 is one of my solutions. 11 minus 9 is 2, and 2 divided by 4 is 1/2. Those are my 2 solutions. 5.5. Two more. A is negative 7. I'm sorry. A is positive 2. B is negative 7. C is negative 5. If it helps you write down A, B, and C, I'm doing that this time. Just see if that helps some people. I start with negative B. What's negative B? Positive 7. Plus or minus the square root of square B minus 4 times A is 2 and C is negative 5. All divided by twice the A value. Let's look at this here, okay? Negative and a negative, that's going to make a positive. And 4 times 2 is 8, times 5 is 40. And 49 plus 40 is 89. So 7 plus or minus the root of 89 over 4. That's a positive solution, isn't it? I mean, that's positive number, so I'm going to have 2 solutions, right? But can you simplify the square root of 89? You can't. So you're done. So part of the deal is you have to understand if you can simplify that or not. Okay? That one's done. One solution is 7 plus the root of 89 over 4. And the other solution is 7 minus the root of 89 over 4. You don't have to write them each out like that. You can just leave it like that. Okay? That's what that means. Last one. Uh-oh, what's different about number 14? Yeah, it's not set equal to 0. So what should I do first? Yeah, I'm going to add the 4. So negative x squared minus 8x plus 4 is equal to 0. I'll list A, B, and C. A is negative 1, B is negative 8, and C is 4. What up, dog? I don't know. He didn't show up to my class yesterday. What should we do, you guys? Should we give him his stuff? This is not for a grade.
Yeah, no, I just got.
Just do your best. Don't look up all the answers. Don't steal Kendall's work. Totally uncalled for. All right. Negative b. Positive 8. Plus or minus square root of. Square b, we get 64. Minus 4 times a is negative 1, and c is 4. Divided by twice the a value. I have 2 negatives, so that's going to turn to positive. I've got 8 plus or minus the square root of, yeah, I got 4 times 1 times 4 is 16, and 16 plus 64 is 80. Is 80 a perfect square? No, it's not. What is the perfect square that divides evenly into 80? Raleigh's got 16 and 5. He's correct. Root of 16, root of 5, over negative 2. What is the square root of 16? I look at these numbers, they're all divisible by 2. And since it's a negative 2, I'm just going to divide it by negative 2. What's 8 divided by negative 2? Negative 4. And 4 divided by negative 2? Negative 2. Since there's a plus or minus, it doesn't, you just write 2. It takes care of the positive and the negative. If you wrote on the test, if you wrote plus or minus negative 2 roots of 5, I give you, it's the same thing. It covers both the positive and the negative, so you don't have to worry about it. Okay? So that's your quadratic formula. Okay? So, we're planning on testing on what day? Friday. Except JC, if she wants to try to get ready for that test on Thursday, she can. I will hand out your study guide and stuff tomorrow. What time do you leave on Friday? So maybe you want to come on Friday and just take this test. That way you get an extra day to review. That's something to think about. You do you, girl. I'm just saying at the end of the day, 4 homework